Okay, hey guys. You've got an exit card coming up on Friday about trig. So I wanted to go over at least these first three homeworks. I think that's what you need to know for the exit card. I'll make another video about 134 and 136 after that, and a third video about 139 and 142. But let's jump into 126. So in this homework, you're just doing the Pythagorean theorem. We're not actually talking about trigonometry yet. So I guess I'll take it back. None of this is on the exit card because you guys already had a check for understanding on this. I'll make the video anyway in case anybody's having trouble completing this assignment. But as far as the check for understanding stuff, you want to be focused on homework number 2 and 3. But anyway, so how do you do this? Well, Pythagorean theorem says that a squared plus b squared has got to equal c squared. And in any right triangle, we said that the hypotenuse is always going to be C, and then the legs will be A and B. And it doesn't matter which leg is A and which leg is B, because you're adding them together anyway. And order doesn't matter when you add, but it is super important to make sure that for C, you always plug in the hypotenuse. So for this problem, you're going to plug X in here. And the 7 and the 10 can go in for A and B in whatever order. But let's say we go 7 squared, 10 squared. Then 7 squared is 49, because that just means 7 times 7. 10 squared is 100, because that's just 10 times 10. Then you just add those up. You get 149. That equals x squared. Then, of course, the way algebra always works is to get x alone, you do the opposite of whatever is being done. And the opposite of squaring a number is taking the square root of it. So to take the square root, you draw this symbol here called a radical. We're going to take the square root of the right-hand side, which means we have to also take the square root of the left-hand side. And you see we end up with an answer where plain old x is equal to the square root of 149. And we said that stopping right here is probably your best answer. Now you could round off to a decimal if you really wanted to. We could say x is approximately equal to whatever this is, but I don't really want the decimal anyway, so just leaving it is not a bad idea. But let me go grab a calculator and I'll show you guys how to do square roots. Okay, got a calculator. So square root of 149, you hit square root 149. And then if you really want to give me a decimal, you can give me 12.207. No, we're only doing 2 decimal places, right? So 12.21 would be your answer, which you put right here, 12.21. Okay, so that's number 1. To do number 2, let me mess around with this a bit, move the calculator out of my way. Hopefully that worked. So we can do number 2 now. In number 2, we're still going to use Pythagorean theorem, so we're still going to start with a squared plus b squared equals c squared. And again, make sure that the hypotenuse is c. So this time around, 21 is the hypotenuse, so that's your c. Your x and your 19 can be a and b. So when you plug in x squared, will actually be over here on the left-hand side this time. And then we'll get 19 squared, and that'll equal 21 squared. So x squared, that's great. We got to do 19 squared now, so 19 squared. 361. And then 21 squared. 441. So now, to solve for x, to start to get x alone, we would subtract the 361 from both sides. That'll get it to cancel, and you'll get an x squared that equals 441 take away 361. Which you can see leaves us with 80. So if x squared equals 80, then to solve for x, we'll do the same thing we did last time. We take the square root, meaning you just throw a radical on top of both sides. Now the square root of x squared gives us plain old x. And the square root of 80, again, I would just leave that alone. Just give your answer as a radical. Or if you really, really want to, then you can use a calculator and figure out what the square root of 80 is. It should be 8.94. And again, you would say x is approximately 8.94. So either answer is okay. Next one. Okay, so this time, looking at number 3, I'm going to start taking some shortcuts so we can be done a little faster. But again, that's my hypotenuse C. X will be A, 16 will be B. So you know you're just going to do an x squared plus a 16 squared and set that equal to 27 squared. So that's an x squared plus a 256, and that equals whatever 27 squared is. 27 squared. 729 apparently. Okay, so now that you've squared everything, you'll subtract the 252 from both sides, or the 256. You can get that to cancel. Now you've got an x squared. That equals whatever you get here. Let's just use our calculator. We're subtracting 256. And so we're left with 473. So that means our final answer is whatever we get when we take the square root of both sides. So we'll get x equals, and again, just give me root 473. Perfectly fine to just stop here. But I'll keep going just to show you guys the decimal values. So we're going to do square root of 473, and that's 21.75. So that's 3. We can do 4 now. Let me move the calculator again. Okay. So now for 4. Oops. For 4, we're back to x being our variable and x being our hypotenuse. So the legs are going to be these guys, the 5.3 and the 12.8. So to set this up, you'll probably want to do the 5.3 squared. You'll add to that 12.8 squared and set that equal to x squared. So in the calculator, I mean, you can actually just do the whole entire thing. So type in 5.3 squared. And if you want, you can just add to that right away 12.8 squared. And we see we're going to get 191.93. And that equals our x squared. So to solve for x, you'll take the square root of both sides. And you'll get x equals whatever this comes out to. Let's go find out. Second square root, second answer. This will just take the square root of my previous answer. So if I hit enter, then that's giving me the square root of the 191.93. So I'm getting 13.85. And since that is a decimal, I'll round it off. I actually shouldn't be saying that it's equal to x. I should be saying it's approximately equal. So I'll put the little squiggly guy. Not a huge deal. Alright, that's 4. Let's do 5, which means move the thing over again. Alright, so for 5, yeah. So we talked in class about this a little bit. we said, I'm going to just take a picture of this so I can make it bigger. So looking at that figure, we know that this triangle is an isosceles triangle because these two sides are marked as being congruent. And we don't know this for sure, but I'm assuming that this dotted line here is meant to be perpendicular to the base. It would just make sense that it is. And we said in class that this line that's perpendicular to the base also is guaranteed to cut the base exactly in half. Now that's only true in an isosceles triangle, but since we're an isosceles triangle, we can bank on that side right there getting cut in half. And that means if I draw this green triangle, then this green triangle is a right triangle. I could then essentially just ignore the bottom. And if I'm trying to solve for x, then I'm trying to solve for that x up there. I can ignore this 18. That 18 is really just there so that I can say that I want half of 18, and this leg here would be 9. So you get a leg of 9, a leg of 20, and then you're solving for x. And finally, we're back now to just a regular Pythagorean theorem problem. We know that to solve for x, we would do 9 squared plus 20 squared equals x squared. And I know that 9 squared is 81. And I know that 20 squared is 400. So that would mean that x squared is equal to 481. So that means that x is actually the square root of 481. And that's it. And we could go to the calculator if we wanted to figure out what the square root of 481 is. So I'm getting 21.93. And again, that would not equal x, that would only be approximately x because that's a fraction, or a decimal, I mean, that we rounded off. But there's your answers for 5. Let's go do 6. All right, so in 6, you're actually looking at like a trapezoid, but the two ends of the trapezoid are right triangles. Just gonna make this bigger. That's plenty big. So the trick to this problem was that to solve for x, if x is this red piece up here, then we kind of know that we could take that red piece and just drag it down. And then this chunk down here between the two right triangles, that's going to be what x is. So I can use the right triangles then to figure out what this blue piece is going to be. The blue piece starting here going to this end. And I could figure out what this green piece is over here going to this end. And we can see that those three green pieces together all add up to the 31. So this red piece in the middle is what we want. And what do we know? We know that this side's 19, but it says right here that that side is the same as this side, so that's 19. We know that in trapezoids, the opposite sides, the top and bottom at least in this one, are parallel. So that would mean if this height is 17, then this height's 17. So it turns out that these two triangles are congruent. You've got 19 and 17, 19 and 17, you've got right angles. We're congruent. So whatever this blue guy is, we've already got a variable called x. So we'll call this blue guy y. And I think we can all rest assured that this green guy is also y. They're not actually different, they're just the same thing. So before I can solve for x, I have to solve for y. And I just do Pythagorean theorem. For y, we would say that y squared, that's one of our legs, plus the other leg, 17 squared, equals the hypotenuse, which is 19 squared. So that means that y squared plus, I think this is 289, and 19 squared, I'm actually not sure. I'm not gonna guess. 19 squared is 361. So at this point, you'll subtract 289 from both sides. Which the calculator tells me leaves only 72. So that means y is the square root of 72, and the square root of 72 is worth approximately 8.49. Alright, now that's great and all, but we weren't actually asked to find y. We were asked to find x. So to find x, we should probably grab the y, and we know that 1y plus an x plus a y altogether equals this whole base, which is 31. So that tells me that the x that we have plus y, which is 8.49, plus another y, so another 8.49, well, that would all equal 31. So if I add this up, I get 16.98. And so we can see that x will be just whatever we get after we subtract 16.98 from both sides. So it'll cancel. We'll get x equals the 31 minus 16.98. So let's do that. 31 minus 16.98 leaves 14.02. And that's 6 for you. So again, x is kind of the real answer. We were supposed to solve for x, but to find x, we had to find y first. All right. One more question? Two more questions? All right, there's two more. So for number 7, looking at this, I do see another right triangle. We're trying to solve for x, and so x is the is the hypotenuse of this red right triangle. But I don't have all the dimensions I need. One dimension I can find pretty easily because I know that this side here is 16, and I see that this whole side is marked as 44. So to find this piece here that I'm marking in green, you would, oh, sorry, you guys can't see because of the calculator. I'll move it over. There you go. Anyway, I was just saying that up here, the 44 is this total distance across. Then you've got 16 that I marked in blue. And we want to find the green. And of course, to find the green, we'll just do whatever 44 minus 16 is. So that'll make a 3. That's a 14. So 14 take away 6 leaves what? 8. And 3 take away 1 leaves 2. So I'm saying this green is 28. Problem is, we still have another value that we need. And that's this orange height here. That would be the other leg in the red triangle. Now to find that, we would need to use the orange triangle. So this is another, I guess it's technically a 3-part problem because we had to do 44 minus 16 just to find this green dimension. Then in the orange triangle, we got to do Pythagorean theorem. So we'll take the hypotenuse first. And what are we going to do? Call this y. So to solve for y, we know that 16 squared plus y squared is going to be 22 squared. So that's a 256 plus y squared equals whatever 22 squared is. 484 apparently. And so now just subtract 256 from both sides. Those will cancel. You now have y squared all alone on the left. And if I do the subtraction, 256 we're left with 228. So that tells me that plain old y, if I take the square root of both sides, is the square root of 228, which I can figure out is approximately 15.10, I guess is what we're calling that. Okay, but remember that's not the end. What we're really supposed to be solving for is x. So now, if you grab this red right triangle and kind of just pull it out, what we really want to solve for is x, which is the hypotenuse here. We did the math earlier up here in green to figure out that this side was 28. And then we just did the math over here for this orange dimension, this vertical side called y. And we know that's the 15.10. Although, I don't know that I would use decimals here. I've been telling you guys to use radicals, so why not just leave this side as 228, or square root of 228? So now if you go to solve for x, then you'll grab those two legs, which is the root 228, and you'll square that, and you'll add to that a 28 that's squared, and that'll equal x squared. And again, I'm probably behind the calculator, so let me move it again over to there. All right, but now the square root of 228 squared, it's easy to square those because anytime you square a radical, the radical and the exponent just cancel out, and you get back this number that was underneath. So I know this whole thing is just going to be a 228. Then I need a 28 squared, which is apparently worth 784. And that equals x squared. So now you just add those two numbers up. We're going to add 224. Is that the right number? Yeah. No, 228. Okay, add those up, you get 1012. And that equals x squared. So to finally solve for x, you just take the square root of both sides. And you either give me x equals the square root of 1012, or you give me x is approximately whatever the square root of 1012 is. So 31.81. All right, there's just the one question left, so let's finish it off. It says Scott is using a 12-foot ramp to help load furniture onto the back of a moving truck. Okay, moving truck. That probably looks something like this. Truck, 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 truck. Okay, here's the top of the truck, and it comes down like that, and it's got a tire on it, and this has tires too, and this should probably be connected. Okay, great, there's my truck. Importantly though, you know what, I should have done a better job with my truck. What I meant to say was, here's the tires. It's got big fat tires on it, okay? And the reason that's important is because here's the street. Well, there's a distance. There's a distance you have to get up to the actual back of the truck. That was supposed to be a different color. But if you were trying to wheel some stuff up into the back of this truck, then you'd need a ramp. Like this. And then you could wheel your stuff up the ramp, okay? So given that idea, they said a 10-foot ramp, and I'm not sure it's actually super obvious which side of this triangle should be the 12. So let's keep reading. It says the back of the truck is 3.5 feet from the ground. Well, that's definitely this vertical distance. That's the 3.5. I feel great about that. I don't want to mess up my drawing, so I'll label it like that. It also says, what's the horizontal distance from where the ramp reaches the ground to the truck? So that horizontal distance would be this dimension here. And that's what we want to solve for. So we can call that x, or we can call it d for distance. I'm going to call it d for distance. But that tells me that, okay, I'm pretty comfortable now, that when they said a 12-foot ramp, they meant the length of the actual diagonal part. This is the 12. Okay, but now that this diagram is fully labeled, then we're back to just doing a regular old Pythagorean theorem problem. And we know that that means we're going to be doing a 3.5 squared. Where's my, oh no, my beautiful drawing. What a shame. What a shame that you guys couldn't see that beautiful truck. I think you'll live. Alright, so anyway, there's my drawing. So looking at that light blue triangle, we can see that one of our legs is 3.5. So in Pythagorean theorem, we'll do 3.5 squared. We'll add to that the other leg, which is our variable, so that'll be d squared, and we'll set that equal to our hypotenuse squared, which is 12 squared. So 12 squared I can do, that's 144. 3.5 squared, I don't know what that is. So do it in your calculator. 12.25. And then that's plus d squared. So now to solve for d, we got to get d alone, so we'll subtract 12.25 from both sides. And we'll see what that gives us. This cancels, and we get a d squared that equals 144 take away 12.25. Leaves 131.75. So we can finish this off by just taking the square root of both sides now. And that gives us a distance that is equal to whatever the square root is. Uh, 11.48 if we round correctly, 11.48. And you should give the correct units. Is this 11 inches, 11 feet, 11 meters? Well, it says up here, a 12-foot ramp. So they're giving you the units there, 3.5 feet. So this is definitely feet, not meters, not yards, just feet. Make sure with word problems that you include those units, though. That's going to be important. All right, I'm going to go to bed because it's gotten quite late. But I'll get this video posted for you guys, so you'll have at least this. But really, it's the next ones that are important. Your exit card on Friday is going to cover trig. So make sure you watch the next videos on the page 129 homework. And 131. Yeah, you need that too. I think you also need 134. Yeah, you definitely do. 136 you do not need, okay? But make sure you know how to do everything from 126 to 129 to 131. All right? Have a good one.